So last lesson, guys ready to start please? Last lesson was a little bit of an introduction to series. We learned a little bit of terminology and how to find some terms and things in our sequences. But there are two main types of sequences that we're going to learn about in this topic. And the first one we're going to focus on today, which is an arithmetic sequence. We've already kind of talked about this yesterday. An arithmetic sequence is one where the terms differ by a common difference. So the ones where you're like adding on 5 each term, or you could be subtracting as well, subtracting something to get to the next term each time. But we're going to be calling that number that you're adding and subtracting, the common difference, and we're going to give that the letter D. Guys, settle down, please. Concentrating. Yesterday, we learnt some notation. First term is T1, second term T2, third term T3, and so on. They are the first 3 terms of our arithmetic series. If we're trying to find a common difference, hopefully it makes sense that you just want to subtract 2 terms in that sequence. So here is a little formula for it. The difference is T of n minus T of n minus 1. Now, it does say there that n must be greater than 2, because obviously if you'll have a series, you're going to want to subtract the second term minus the first term. You're never going to do the first term minus 0 or something before that, okay? It would have to be second minus first, or you could do third minus second, or even 10th minus 9th. It doesn't matter as long as it is the second 2 consecutive terms and the higher place valued one minus the one before it, okay? Alternatively, you could rearrange that formula, and you wouldn't do this most of the time, but this is similar to what we were writing yesterday when we were trying to find rules for things. The T of n would be equal to the previous term plus the common difference. They were rules we were writing down yesterday, and it's just a rearrangement of that first one over there. The nth term of a general arithmetic series can be found with a formula. And this is the formula here. T of n equals a plus n minus 1 in brackets times by d. Now we've already talked about d. D is the common difference in your sequence. A stands for the first term, and the n is the position of the term that you want. So we're going to find some of that stuff today in our examples. Let's have a look. Example number 1. Here are the following sequences. We want to find out whether they are APs, that stands for arithmetic progression, or not. If they are, state the A and the D. Looking at that first progression of numbers there, we start with 3. We would have to add 4 to get to 7. And if I add 4 again, yes, I get 11. Add 4 again, yes, I do get 15. So I'm adding a constant number each time. So that is going to be an arithmetic progression. So I'm going to say yes. So that means I want to find out what A is, and I want to find out what D is. A is the first term in that sequence, so it's going to be the 3. The D is what the difference is each time, and it is the 4, yes, that I've calculated here, or you just go 7 take away 3, which gives you the 4. Part B. Let's have a look again. Starting with 2, we would have to add 6 to get to 8. If I add 6 again, do I get 14? Yep, so that's another plus 6. If I add 6 again, do I get to 22? No, what do I have to add there? 8. So because that has changed, that is not an arithmetic progression, so we're going to say no. Because it doesn't fit the type of sequence that we want, we cannot find A, we cannot find D, that's it. Going on to question 2. Write down the first 5 terms of an arithmetic progression if A is equal to 67 and D is equal to -4. So if A is 67, that's my first term, 67. Putting a minus in front of the D means that they're going to be going down by 4 each time. So subtract off 4, we get 63. Subtract off 4 again, we get 59. Subtract off 4 again, 55. Subtract off 4 again, 51. That's 5 terms, so we can put a comma and some dot dot dots if we did want to. That sequence could continue, but we have found the first 5. So part B says to find the 30th term. You do not want to be writing out 30 terms continuing this pattern here, okay? This is why we have a formula. If I want to find a term, where is my formula? Way back here. If I want to find a term in an arithmetic series, that's the one to use. So I'm going to write it down. T of n equals a plus n minus 1 close bracket d. Now, you don't have to do this, but some of you may find it beneficial. I'm going to write down what each of those letters are. A is going to be the 67, the first term in the sequence. The D is what it's the difference. It's going down by 4, so minus 4 for D. And the other letter that I have is N, and it tells me I want 30th term, so that means my N is going to be 30. Okay, so now it's just a matter of substituting those things into that formula. Instead of T of N, I can write T of 30 to say that's the 30th term. A is 67 plus N minus 1 will be 30, take away 1, and times by the minus 4 at the end. I don't know why they put the D at the end. Sorry, what did you say? Minus 49, correct. Okay, done? Next one. Find the general term. The general term, we did do some of those in the first exercise, means we want to have an equation that has the term represented by n still in the equation, right? So we're still going to use a is equal to 67, and the difference is still going to be equal to negative 4, but we want it for any value of n. We want n to still be in there. So using my same formula, T of n, my term, is going to be equal to A is 67 plus n minus 1, we're leaving the n in there this time, so it stays n minus 1, times by D, which is negative 4. And all I'm going to do is expand that out and simplify it a little bit. So I don't know why they've decided to put the D at the end of the bracket, because it makes it a bit of a pain to expand, but imagine that that minus 4 is at the front of this, and we're going to expand that through there. So that is 67 minus 4 times n will be minus 4n. Minus 4 times minus 1 will make a plus 4. Collecting like terms, 67 plus 4 makes 71 minus 4n. Okay, so that means any term now could be found. If I want the 20th term, I just sub in that n is equal to 20. I want the 100th term, I sub in that n is equal to 100. I can just put it into that formula. There is another part to this question. Part D says to find the first negative term. So we could see, if we think back to part A, our series was starting at 67 and it's going down. 67, 63, 59, 55, they're going down. When is it going to hit that point 0 and go into the negative numbers? Okay, so we did this yesterday. What we did was we said we want to find when the term is going to be less than 0. So my equation for my term, I've left it here so we can still see it. My term is 71 minus 4n is less than 0, and I want to solve that to find n. So the first thing I'm going to do is subtract the 71 across to the other side. So it's negative 4n is less than negative 71. Then I'm going to divide by a negative 4. When you have an inequality and you divide by a negative, you turn the sign around. And 71 divided by 4 makes 17.75. Okay, so it's not, 0 is not one of the terms of the series, but we want to find the first one that's going to be negative, which will be the next number bigger than that, which will be 18. So over here, I'm going to say when n equals 18, because I actually want to find out what this first negative term is. And I had to sub the 18 back into my formula to find out what the term is. So that will be t of 18, term 18, is going to be equal to, I'm subbing it into this one here, 71 minus 4 times 18. Anyone get it? Negative 1. First negative term is negative 1. Okay, that's the end of question 2. Question 3. The nth term of a sequence is given by t of n equals 4n minus 5. So I'm giving you the general rule for this sequence. Which term of the sequence is equal to 35? So all I'm wanting to do is find out when t is equal to 35, and I want to find out what n is. And I'm going to put it into that equation that it gave me. So the t of n is the 35 equals 4n minus 5, and solve the equation. Add 5 to the other side, 4n equals 40, and dividing by 4, we get n is equal to 10. Nice whole number because it is a term of that sequence. So that means the term that we're after, the 35, is the 10th term. You can double check that if you're ever in doubt. If you sub 10 back into here, 4 times 10 is 40, minus 5 is 35. We get our number back again. Question 4. How many terms are there in the sequence? 27, 31, 35, ... all the way up to 547. This is what we call a finite series because we have a last term, a last number. Okay, and we're trying to find out how many terms there are coming up to that last number of 547. So we're just going to make our term, our t of n, equal to the 547. What other things do we know about that sequence? Thinking of our formula, do we know an A? A is 27, good. Do we know a D? We sure do. This sequence is going up by 4 each time, so D is going to be equal to 4. Putting those things into our formula, which I'll write down for you. T of n equals A plus n minus 1 in brackets D. We're trying to find the n. So you could put over here n equals question mark. That's what I'm trying to find. T of n is the 547. A is 27 plus n I'm trying to find, but D is 4. Okay, I don't have to expand. I can just start moving things away from that n. So first of all, subtract the 27 across would be 520 equals, I'm going to put the 4 out the front because I like to have 4s in front of my brackets, not behind them. Then I can divide the 4 across to the other side, which would give n minus 1. I don't actually need the bracket anymore if I'm dividing the 4 away. N minus 1 equals 130. And finally, last step, add the 1 over. N is going to be equal to 131, which I have just, that means that there are 131 terms in that sequence to get all the way up to 547. All right, one more, question 5. If an AP or an arithmetic progression has A equal to 623 and the 10th term is 551, find the common difference. So it's already, I wasn't going to rewrite it because it's already there, that's why I highlighted it. A is equal to 623. The 10th term, that means T10 is equal to 551. Telling me that it's the 10th term is also telling me the n is equal to 10. So in the formula, sub all those things in that we know, and we're trying to find the common difference. So T of n, or T10 actually, is 551 equals A is 623 plus, open a bracket, n is 10, 10 take away 1, and we're trying to find the D. Solving that equation, subtract the 623 across the other side. That gives you negative 72. 10 take away 1 in the brackets is 9D. And then you just need to divide by 9. So D, negative 72 divided by 9 is negative 8. So the common difference is negative 8. That's it. So 1B there will be all about arithmetic progressions, and then next lesson we'll go on to 1C, which is the other type, the geometric.